This brief tutorial and demonstration will cover the differences between a hub acting at layer 1, a switch operating at layer 2, and a router operating at layer 3. One of the key elements that you can think of is that a router working with layer 3 is making forwarding decisions based on layer 3 addresses, like IP addresses. A switch making forwarding decisions at layer 2 is making those forward information decisions based on layer 2 addresses, like MAC addresses. And hubs, they're simply making layer 1 decisions, meaning they see a bit or a signal, they're simply going to repeat it. They have no intelligence or no knowledge of any kind of intelligent addressing or anything else. They're just simply repeaters. Let's take a look at each of those in order. We'll start with the hub over here first. This hub has 4 ports in this current diagram anyway, and these 4 ports, it works like this. Let's take PC1. If PC1 sends information down to the hub. Now you and I both know that the OSI reference model, how that works. When we physically send information into the network, we're sending bits. Well, that's what the hub is making forwarding decisions based on. Ooh, I see a bit, and what is it going to do? It's going to repeat that information off of every single other port. It doesn't matter if it was a broadcast, it doesn't matter if PC1 was trying to talk to PC2, the hub has no knowledge of it. It simply takes the data in and forwards it out every other port. So in that sense, we have one VLAN, one broadcast domain, and one giant collision domain. Let me explain that for a moment. A VLAN, or a broadcast domain, is how far a broadcast will go in the network. Well, if this PC sends a broadcast, it's going to go to every single port. That means every device is going to see it. That's one giant broadcast domain, the grouping, if you will, of people who would see a broadcast. It also happens to be one giant collision domain, because as this PC is sending, and if another PC tries to send at the same time, there could be a collision. They're all competing for bandwidth. Only one speaker can be talking at a time successfully with a hub, because there's no intelligent separation of conversations. So the hub is one giant broadcast domain. The hub is one giant collision domain, and it's got and that's enough. That's a great start, and it makes its forwarding decisions based on layer 1 bits coming in. Let's compare and contrast that over to a switch. The switch over here we'll do in red. The switch over here also has 4 ports, but it's intelligent. It's memorizing MAC addresses. And just for grins, let's say that PC2 has a MAC address of 2222 dot and a whole bunch of other 2s. And PC1 has a MAC address of 1011 and a whole bunch of other, it's 48 bits in a MAC address. So what the switch does, it looks at the source MAC address and it memorizes where everybody lives. The switch would know that if it needed to reach the layer 2 address of 222, etc., it would use FA03. It would know to reach 1011, etc. It would know to use FA02. It's intelligent. It's learning, and that's why they cost a little bit more than a hub, by the way. So as they're learning, how does that bias anything? Well, check this out. If this PC wants to talk, PC2 wants to talk to PC1 and is forwarding a frame destined for 1011, etc., the switch, knowing and making forwarding decisions based on layer 2 addresses, is going to take that data and do this. It's going to come in on FA03 and it's going to go out on FA02. Guess what? This PC down here on the bottom left and the router never had to see any of that traffic. What's going to happen is that we're going to have additional throughput as a result of this, and check out what else happens. The switch gives everybody full bandwidth, full duplex capabilities on the wire. The PC0 could be talking to the router, and PC2 could be talking to PC1, and there will never, ever, 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 never, in a perfect world, be a collision. On the back plane of the switch, it keeps all those conversations separate. It uses one pair of wires for sending and another pair of wires for receiving to each device, and it can use those both simultaneously. So there's no collisions ever, and that means that if I have 4 ports on a switch, I have 4 collision domains, or the domains where a collision could happen. So I've got a collision domain here on FA03, and as a result, because there's only one PC on it, guess what? There's never going to be a collision. I've got another collision domain, FA02, never going to be a collision on it because there's only one host. It's like having your own dedicated road. Like, who are you going to crash into? Well, I guess you could go off the road, but you're not going to crash into another car because you've got your own dedicated road. So comparing that to a hub, this hub up here has 4 interfaces, but 1 giant collision domain. This switch has 4 ports, but because it's a layer 2 switch, and it's running full duplex, it's going to be it's going to be 4 individual collision domains. Now, let's take a look at what happens when a broadcast occurs. If this PC2 sends a broadcast is an address that the switch will never memorize where it lives because no one ever sourced a frame using a broadcast. The switch is going to forward broadcast to all other ports in the same VLAN. So if these 4 ports on the screen were all assigned to VLAN 1, as an example, a broadcast sent from PC2 would indeed go out. The FA02, the F02, the FA01, and the FA04 interface, because these ports are all members of the same VLAN or broadcast domain. So as a result, over here we have 1 giant broadcast domain. A broadcast would go to all 4 devices. I take that back. A broadcast source from this interface would go to all other interfaces in the VLAN, which would be 3 others. But that's the same as on the hub. Over here we have 1 giant broadcast domain. Now, it's 1 giant collision domain too for everything else, but from the broadcast domain perspective, this hub and this switch are on the same turf. They're each 1 giant broadcast domain, unless we carve him up into separate VLANs. All right, so what's next? Well, let's take a look at the other step that often gets people a little bit crazy, and that is layer 3 addressing. Well, these PCs over here all need to have, because they're on the same broadcast domain and they happen to have the same collision domain, normally we'll assign all of them a logical IP address on the same subnetwork. So maybe we give all these guys I'll use blue. I change my colors here. So maybe we give all these guys the address of 10.0.0.0/8. And over here on the left, we give these guys a logical IP network address space of 20.0.0.0/8. You with me? And we control that. I mean, the switch and the hub in this case have no cares. They don't know what the layer 3 addressing is because they're not layer 3 devices, neither one of them. So in a pure layer 2 environment, for example, this switch is making layer 2 forwarding decisions, and it doesn't really pay attention to layer 3 until we introduce layer 3 switches, which later discussion. So here's the scoop. These guys can all talk to each other using this logical layer 3 address. Normally, one subnet, like the 20 network, would go in conjunction with 1 broadcast domain. You don't have to, but it makes a lot of sense to do it. Over here on the 10 network, we've associated the 10 network with 1 logical broadcast domain over here. This router, by the way, is the magical device that understands how to make forwarding decisions based on layer 3 addresses. So because he belongs to this broadcast domain, and we've given him an IP address of 10.0.0.1 over here, and an address of 20.0.0.1 over here, if all these PCs used him as a default gateway, and all these PCs use him as a default gateway, and he knows how to forward traffic between those 2 subnets, or those 2 networks, that would be its job in life. Now, routers never forward broadcasts. So broadcast domain ends at the edge of a router. I mean, he'll receive broadcasts from this domain, but he'll never propagate them. So as a quick review, I want to keep this under 10 minutes, which we're almost to that mark, is that hubs make forwarding decisions based on layer 1 bits coming in. Switches make forwarding decisions based on layer 2 information. And routers make forwarding decisions based on logical layer 3, such as IP addressing information. And that's the nuts and bolts of it. I hope that helps you, and I wish you the best of luck. Thanks, everybody.